Good morning to one and all. This is Seri Meenakshi, Assistant Professor of Mathematics from Fatima College, Madurai. And in the previous class, we have seen how to find the optimum solution of the given linear programming problem using graphical method. And we analyze a special case in it, right? And this is another special case. Let's see the problem now. So, read of the problem. Solve the following LPP using graphical method. And the objective function is maximize z equal to 6x1 plus x2 subject to the constraint 2x1 plus x2 greater than or equal to 3, x1 minus x2 less than or equal to 0, and finally the non-negative restriction x1 x2 greater than or equal to 0. And let's see about the solution. First we have to plot these lines in a diagram. For that we have to first find the point that the lines intersect the x1 and x2 axis. And for the first constraint, we have to consider only the constraints now. Whatever the inequalities will be, you have to consider this as equation and find out the points. See the first constraint, 2x1 plus x2 equal to 3. And how to find these points? By putting x1 equal to 0 and the value of x2 will be 3. And if you put x2 is equal to 0, the value of x1 will be 3 by 2. So, likewise, we have to find out the points for second constraints. And what is the feasible region? It is the intersection of all the regions represented by the constraint, and it should be restricted to the first quadrant. And these are the points which is on the first constraint, and these are the points which is on the second constraint. Let us draw the x1 axis and x2 axis and plot the point 0, 1, 2, 3 on x1 axis and 1, 2, 3 on x2 axis. Plot these points and draw the line for the first constraint and draw the second constraint. Next we have to find out the shaded region. How to find the shaded region? So we have to take any points. For example, for the first constraint, since it is greater than or equal to 0, the shaded region should be away from the origin, which means for the first constraint, the shaded region should be on the right hand side of the constraint, right? And what about for the second constraint? How to find the shaded region? Take any point. For example, for my convenience, I have taken 1, 0. Okay, substitute these points in the second constraint. 1 minus 0 less than or equal to 0, which means 1 is less than or equal to 0. Whether the inequality is correct? No. Which means what I have chosen from the side, which means 1, 0 என்ற point right hand side choose பண்ணிருக்கேன். அப்படி apply பண்ணும்போது that inequality is wrong. Which means நான் choose பண்ண அந்த region தப்பு. Which means the shaded region should be opposite side. Which means left hand side of the constraint. Which means left hand side of the second constraint. So the intersection part of the both the shaded region will be like this. Okay, find out the corner points and see the objective function. Objective function is maximization type. Here the feasible region is unbounded. We cannot able to find out the maximum value. So the optimum solution is the unbounded solution that is given over there. Now we are going to compare the first problem and the second problem. The first problem and second problem, the feasible region is unbounded. There also the feasible region is unbounded. Here also the feasible region is unbounded. And the difference is, there the objective function is minimization. ஒரு unbounded feasible region unbounded ஆக இருக்கும்போது அதோட minimum value கண்டுபிடிக்க முடியும். Maximum value நம்மளால கண்டுபிடிக்க முடியாது. The first problem it is given as minimization. அதனால corner pointsலாம் கண்டுபிடிச்சு அதோட minimum value போட்டோம். That is the optimum value. Here they are asking maximization. So இதோட maximum value நம்மளால கண்டுபிடிக்க முடியாது. So here the optimum solution is unbounded solution. Right? So that is the main difference between the first problem and the second problem. The next case we'll see it in the next class. Thank you.